Good morning, everybody. We are moving on to a new topic this week. We're going to talk arcs and sectors and circles and a bunch of different things this week. We're going to kind of get away from that right triangle trig that we did last week and work really now with some circle stuff. So we're going to start today with arcs and sectors. So let's look at a few things. So an arc is all the points on a circle between two endpoints. When we denote arc, we denote it with two capital letters and then a little arc over the top of it. This means arc with the endpoints AB. You understand that these are endpoints on a circle. So there's our circle. There's points A and B. The arc is the piece between them. So we call that arc right there, arc AB. Right, so that is arc AB. It is intercepted by the angle at the center O between the radius B and the radius A. So we can put in there what we call an intercepted angle, or this is also called a central angle. And that central angle is created by taking a radius from both your A and B value, and then that central angle is created, or an intercepted arc, for example, is with that center sitting right there. And again, this is called a central angle. So a central angle of a circle is an angle whose vertex is at the center. In this case, angle AOB is a central angle, and the angle is represented with the variable theta. Just like we did with right triangles, we represented that angle. So we call that the central angle, and we can then go ahead and find theta. Now, the part along it is called the arc. So we have arc AB. So this right here is arc AB. And we're going to work on finding that length of the arc. And that's one of the things we're going to do today. Is how do we go about finding the length of the arc? And if you think about it, it's a circle, and we're just doing a certain portion of a circle. So we're just going to do a fraction of how we would find what would be the circumference of a circle. And we'll talk about that in a little bit. A sector is all of this stuff. So this is a sector. So the region contained between the arc and the two radius is called the sector. So in this case, this is sector AOB. So the arc is the kind of the outer part of it. If you think about a wheel, it's your tire. Okay. If it's a pizza, the sector is your whole slice of pizza, where the arc would just be like the crust. The sector would be the whole piece of pizza. And I think that's one of the problems we're going to do in a minute. It's going to talk how you find the area of this piece of pizza that you get. Okay, so we've got a central angle. We've got a sector, we've got an arc, we've got all of those different types of things, and of course, it filled it in there. Now we have what's called an arc addition postulate. Now the arc addition postulate says this. It says the measure of an arc formed by adjacent arcs is the measure of the two arcs. So if I take the measure of arc A, B, C, which is this whole arc right here, when we're naming arcs, you can either have what's called a major arc or a minor arc. 3 letters is going to be a major arc. Okay? And when you're doing the arcs, you have to follow the letter. So it's that arc. So what the arc addition postulate says is it says that that arc is equal to the measure of this arc plus the measure of that arc. So if we tell you that this is 60 and this is 140, the measure of arc ABC is going to equal 60 plus 140, which is 200 degrees. That's the measure of that whole arc. Where did the 60 and 140 come from? You just kind of made them up at this point, okay? So that's called the arc addition postulate. And they gave a different example, but that's okay. Okay, so now let's talk about that central angle and kind of that arc measure. Now, one thing you need to understand is that if you know the measure of the central angle, the measure of the central angle is exactly the same as the measure of the arc that it creates. So if we look at this first example, I've got all of these things coming along, and it says it wants us to find SWV. So SWV, it wants us to find essentially that angle right here. And now what you need to understand is that the measure of the arc is the same thing as the measure of the central angle. So since the measure of this arc right here is 35 degrees, the measure of this central angle is 35 degrees as well. Since the measure of this arc is the central angle is 95, the measure of this arc is 95. Since the measure of this arc, a central angle is 160, the measure of this arc is 160 as well. So the measures of the central angles is exactly the same as the measures of the arcs in degrees. Okay, so when you think about a circle, we know that a circle is 360 degrees. So if we're using kind of that angle postulate from the last video, if we think about what we need to know here, we know all the way around here, we can calculate those. If I take 35 plus 95 plus 160, that's going to give me all of the arcs that I have. So 35 plus 95 plus 160 is 290. So I have 290 degrees of the circle. I just need to figure out what the rest is. So this arc right here is going to be 360 minus 290, which is 70. And if the measure of the arc is 70 degrees, that makes the measure of the central angle 70 degrees as well, because the measure of the central angle is the same thing as the measure of the arc, and those are going to be equal to each other. Okay, let's look at number 3. Number 3, it wants us to find KL. Okay, so it wants us to find that arc right there. Okay, well, we know this is 109 from J to N. The central angle is 40, so we know this is 40. Let's see, what else do we know? Well, if you look at this line right here, that line right there appears to be a diameter. Okay, so diameters add up to 180, right? But this one also appears to be a diameter. So in a straight line. So a straight line has to add up to 180. So if I know that this distance right here is 109, that distance right there is going to be 180 minus 109, which is 71. Now if you look, angle 1, angle 2, and that 40, they form a straight line. Well, we know angle 1 is 71 degrees. We know that angle down there is 40 degrees. So if we go 71 plus 40, we get 111. And this angle here, this angle here, and this angle here have to add up to 180. So if I subtract what I already know from 180, I get 69. That has to be the measure of KL. Okay, so you got to do a little bit of deduction here when you're doing these. Remember, diameters are 180 degrees. The central angle is the same thing as the arc. The arc is the same thing as the central angle. And that diameter forms a straight line, and we talked about that already. That's a long time ago. The measure of a straight line is 180 degrees. So we can kind of work through these when we do them. Go. All right, so let's take a look at question number 5 down there. It says, find the measure of STR. So I'm going to mark STR first. Now remember, when you're doing arcs, I said it at the beginning, you have to go in alphabetical order. You have to go in the order that it goes. So STR is way over here. Okay, so let's think about what we have here. So we have a diameter right here. So we know this angle is 70 degrees. So this has to be 110 because those have to add up to 180. That makes this 110 as well. So now the arc the arcs are the same as the central angle, so if we add 110 plus 110 plus 70, that's going to give me the measure of that whole thing, which is 290 degrees. Okay, so keep in mind when you're doing these central angle ones, the central angles and the arcs, measures of the arcs are exactly the same. You've got to do some adding up. Remember, the diameters are 180 degrees. The full way around a circle is 360 degrees. The next one, okay, now just because we had variables in there doesn't change things up from what we just said. We want to find the value of x in this problem. Well, remember, arcs measures are the same as the central angles measure. So if I have that this is 12x plus 13, this has to be 12x plus 13 as well. What's the distance around a circle? It's 360 degrees. So if I add all of these up, they have to add up to 360 degrees. 7 and 13 is 20. That's 32 x's. We've got negative 11, that's 2, so that's plus 8. Equals 360. Subtract 8. 32x equals 352. 352 divided by 32. We get x is equal to 11. Right? So don't let it confuse you if they throw variables in here. You know the distance around a circle is 360 degrees. So they all have to add up to 360 degrees. The measure of the arc is the same thing as the measure of the central angle, so on and so forth. Okay. So now let's talk about finding the area of the sector. How do we go about finding the area of a sector? Well, the area of a sector is just a fraction of the area of a full circle. And we can find the fraction by dividing the arc measure by 360. So if we know that arc measure, we can divide that by 360 to figure out what part of that sector that we need to know. So for in this example, we've got a sector of a circle. That central angle is 72 degrees, and it has a radius of 6. Okay, well, the area of a sector then is going to be, in this case, 72 divided by 360 times pi times 6 squared. Because remember, for a circle, the area of a circle is pi r squared. So to find the area of a sector, we're just going to go with the arc divided by 360 times pi r squared, the measure of your arc, divided by 360 times pi r squared, which that is that right there. And then they just calculated it out to the nearest hundredth. So you just do it all on your calculator, and you get 22.62 centimeters squared is the area of that sector. So that's all of this stuff in here. It's kind of that area of the pizza type of situation, okay? Okay, so here's just kind of a basic of how you find the area of the sector. For any circle, radius r, center is this. Okay, so the area of a sector is theta, the central angle, or the measure of the arc, divided by 360 times pi r squared. Okay, and that's how you're going to do this. This is just another way to write it. So let's look at this pizza example. The pizza shop wants you to make a pizza called the 8-taste pizza, where there's one slice of each topping. There are 3 slices of pizza, each with different diameters, small, medium, and large. Calculate the area of each slice to the amount of toppings required that can be determined. So let's say we're just going to do the large. The diameter of the large is equal to 12. So my diameter right here, that's going to be 12. Now, it says it cuts, there are 3 sizes of pizza, blah, blah, blah. Now, when we cut this pizza, it looks like it's cutting it into 4 slices on each part. So 180 divided by 4. So each of these angles is 45 degrees. Now, to find the area of this large, and we're just going to do the large, we need to do the central angle, or the arc, divided by 360 times pi times r squared. If the diameter is 12, what's the radius? Well, the radius is going to be 6. So 6 squared. So I'm just going to go 45 divided by 360. I'm going to hit enter. Times pi times 6 squared. And I get an area of 14.1 inches squared is the area of that piece of pizza. So there are 14.1 little 1 by 1 inch squares in that pizza. But remember, you need to know the radius, not the diameter. You need to know the radius. Okay, they did a different one, which is fine. Okay, so let's look at a couple more. Okay, so in question number 11, we want to find the area of this sector right here. Well, we know that it's 240 degrees out of the 360 total. It's going to be times pi times our radius, which is 7 squared. 240 divided by 360. Make sure if you do it that way, hit equals after the 360. Times pi, times pi. Clear, let's try it again. 240 divided by 360 times pi times 7 squared. You get 102.6 kilometers squared is the area of that one. Okay, go ahead, do number 13 quick, press pause. You sure you got 127.2 feet squared for that one. 45 divided by 360 times pi times 18 squared. So that is the area of the sector. The next thing we want to find is we want to find the length of the arc. So essentially we want to find how long is that crust going to be. And if you think about what that crust is going to be, the crust is going to be that circumference of the circle. So the length of an arc can be used, whatever. The length of an arc is the fraction of the length of the circumference. So it can also be calculated by finding the circumference of the circle using the fraction of the central angle. Okay, so again, that central angle is going to be our theta over 360, kind of that circumference, because circumference is that outside length of the circle. So what's the length going to be if we have a radius that's 6 and we've got this 90-degree angle in there? Okay, so our central angle is 90 degrees. So that's 90 divided by 360, which is a fourth. So it's going to be 1/4 of the circumference of the circle. The circumference of a circle is 2 pi r. So we're going to go 1/4 times 2 pi r, which is approximately 9.42. So for the length, the length is going to equal the arc, or the central angle, divided by 360 times 2 pi r. And that's the formula we're going to use to find the arc length. You put theta there, whatever, the central angle, whatever it is, times 2 times pi times r. Okay, so there's that one. So let's look at a couple examples. Now we want to find the arc length in these. So we want to find the length of these. Make sure you follow the directions. We're not finding the area of this. We're finding the arc length. So we're going to find that distance from there to there. So our central angle is 135 out of a possible 360 times 2 times pi times our radius is 10. So 135 divided by 360, hit enter, times 2 times pi times 10. This is 23.6 meters. It's not meters squared, it's just meters. So from that arc, that length right there is 23.6 meters. Go ahead and do number 19, press pause. So you should have got 31.4 feet for that. And that's that length of that arc right there. So be careful when you're doing your assignment today. That's kind of the end of the slides there. Be careful when you're doing your assignments today and do what they're asking. First part of your assignment is going to be doing those arc measure ones where you got to remember diameter is 180, the full way around is 360, measure of the central angle is the same as the measure of the arc that it creates. Okay, second part of it, you're going to find, I think you probably do the length first. I kind of switched them around in the presentation, but you're going to do the length first. So it's your arc divided by 360 times 2 pi r. That's the arc length. And the last part, you're going to find the area of the sector, I think that's the order, which is the arc divided by 360 times pi r squared. Because remember, it's the area of a circle is pi r squared. Where you're finding the length, that's the circumference of a circle, which is 2 pi r. Okay? Now, your assignment today, in the worksheet, it's there. You only need to do the evens. So I think that's just kind of that, I don't know, I'm backwards here, but you just have to do the evens on there. If you look, we did the odds. That's what we did for our examples today. So you only need to do the evens on your assignments. Make sure we're getting the assignments done and we're keeping up. Some of you are starting to fall a little bit behind, and it's going to cost you in the end. We're probably looking at another assessment this week. So let's keep ourselves going. Go get your homework done right now. Remember, the next day is going to be some videos here with some things going on here at the school. Have a great day, everybody. We will see you next time.